Hello, folks. Can you hear me okay? Thank you so much for joining us today. We are super excited. Infrastructure as Code, a year in review, and we have a lot in this session for you, so we hope there's some really good takeaways for you and your own companies when you're building on our platform. I'm joined today with some awesome guest speakers, Varvara and Brian. Varvara, would you like to introduce yourself?
Sure. Hi, everyone. I'm Varvara. I'm a cloud infrastructure architect, which means that I basically build end-to-end solutions on AWS together with our customers. And I actually spent the last 2 years working very closely with a customer who lives and breathes CloudFormation. So I'm really excited to chat with all of you today about the latest updates to the CloudFormation service.
And I'm Brian. I run the engineering team at Tynes, and we've been a happy customer of AWS services, CDK and CloudFormation, most relevantly to this talk, for a number of years now.
Awesome. Thank you so much. You're going to hear from Varvara and Brian later on in the session, but it's my job today to actually kick us off with our agenda here. So we're going to break the talk into 3 parts. We have what infrastructure as code tools we offer, which I'll cover. Varvara is going to then talk about the cool releases that we had in 2024, 2025. So there's some really good stuff there. And then finally, Brian from Tynes is going to wrap up and talk about how they've used infrastructure as code to actually scale to a global level. So Tynes recently became a unicorn startup, which is awesome. And Brian's been there from very early on. So you'll get some cool insights from his perspective. So why infrastructure as code, right? Infrastructure as code is, to be honest, developers want to be able to do things that they're familiar with, right? So they want to be able to write infrastructure in the same way that they write their application code. And when I break it down simply, right, we'll start from the beginning because I'm sure there's a lot of people who are new to infrastructure as code. So this is just a quick refresher. We have a template you'll see behind me where we're actually defining an S3 bucket. And you can see I have some tags, configuration, and it's in YAML code. So again, what we can do with that code is use a tool, okay, and deploy that into actual infrastructure. So you can create the bucket, you can update the bucket, and there it will be in your AWS account. So think of infrastructure as code. It does the heavy lifting to apply the desired state to your infrastructure. Okay, and this is becoming more and more common and absolute best practice for any customer now building on the cloud. So I'm going to cover the key tools that we offer at AWS and kind of centralize everything into one place so you can see what it looks like. And we have this slide, okay? And don't worry, it might look like a lot, but we're going to break it down bit by bit. And we'll start with the bottom layer there, our AWS services, right? These are the core to the AWS cloud. And on top of our AWS services, you can see CloudFormation, Cloud Control API, and our resource registry as well. So I'm going to talk about CloudFormation in a bit more detail in a moment. But we have the likes of our Cloud Control API. Right? This actually allows you to directly interact with your infrastructure on AWS via an API. So an example of that would be, get me all the S3 buckets in my AWS account. And you can make that API request to Cloud Control, and it'll come back with all the buckets, right? And that's just a quick example. You can update things, you can delete things. So again, a very seamless way to be able to interact with your infrastructure. And again, you'll hear Tynes how they use that too. Resource registry. So this allows you to use actual third-party products with our infrastructure as code. So you can see a few of them there on the slide at the top: Terraform, Red Hat, OpenTofu. An example would be, I want to deploy a MongoDB database into my AWS environment. You can now do that with infrastructure as code. So there's great integrations with our third-party services. There is then as well a top layer. So there we have that middle layer, which is kind of the foundation, and then you'll see the top layer kind of built on top of that again. So the likes of Amplify, SAM, CDK, we're going to touch on those, and our third-party providers. So I know a lot of people, for example, will use the likes of Terraform when using infrastructure as code too. But this is infrastructure as code. So let's dive into CloudFormation. We can't not go into some detail here. CloudFormation launched in 2011, all right? It was absolutely born out of necessity from the beginning. Developers really wanted to use it, so again, very early on in the AWS journey. And with CloudFormation, you can write your infrastructure in typically YAML or JSON format. And it makes it very easy to replicate environments. So you might have a production environment, and you want to replicate it and create a development environment, pre-production, that's all very seamless to do with CloudFormation. You just need to change some of the configurations in the template. It then allows you to make reliable updates. Okay, so if you're deploying new services, maybe updates to your stack, whatever it may be. And what's awesome as well is you can version it. So you can deploy version 3. If you want to make changes, you can roll back to version 2. So again, it's super helpful, and again, a very early on service that has been made by AWS. So think of it as a cheat code for cloud agility at scale. Okay, and it's at the very center of infrastructure as code here at AWS. So when we actually zoom back now, I want to talk about some of those services that are actually they're built on top of CloudFormation. So we have the likes of Amplify, right, for any front-end developers in the room, anyone developing user interfaces or mobile web apps. Amplify is a fantastic way to get started building those, and then you can seamlessly deploy those UI updates to AWS, and it uses CloudFormation. We have as well SAM, which is our serverless application model. So if you're building a lot with Lambda, the likes of DynamoDB, you can build those services locally on your local machine, and when you're ready to deploy them to AWS, you can use SAM to seamlessly deploy. And guess what? It uses CloudFormation under the hood. Okay, so I know there's a lot of serverless advocates around. But one that, again, is worth going into more detail is the CDK. The CDK allows software engineers to actually write the infrastructure as code in a language of their choosing, right? So they can actually write their infrastructure in Python, TypeScript, Java, JavaScript. Like, they're just to name a few examples. And from the developer perspective, why should they treat their infrastructure any different to how they might build the application? So there's lots of different languages. There's tool support. There's reusable constructs to save the developers rewriting, so they can take modular components, apply them to different stacks. Again, very seamless, and again, making it quick for developers to do that. So again, very popular CDK, and is becoming even more increasingly popular. You're going to hear Brian from Tynes talk about how they leverage the CDK to scale Tynes up to this unicorn status. So there are some of on our side, the key tools at AWS for infrastructure as code, and this just gives you that snapshot. And again, I mentioned the third parties, right? They're really good options as well to help develop your code. There's a lot of choice here. So when we break down what our customers want and what the product team are always hearing from customers when it comes to infrastructure as code, there are 3 central themes, right? Developers want to be able to develop quickly, so speed is critical. So if you want to make changes to a stack, developers want it to happen quickly. If you want to make updates, if you want to change things, they also want the stack to roll out super quick as well. So speed in every aspect is critical. Safety as well, right? So if you deploy a stack, you want to make sure that that exact stack that you defined gets deployed seamlessly. So safety is another critical component that we hear from customers all the time. And finally, governance, right? So who did what? And being able to track, create permissions for things. Maybe you want a human in the loop to be able to, for example, approve the launch. All these things can happen. So these are the 3 core themes that we're going to dive into today. Because at this stage, I'm going to welcome Varvara up, who's going to talk to you about the 2024, 2025 releases through these lenses. So Varvara, thank you very much.
Thanks, Jonah. So as I mentioned, thank you. I use CloudFormation every single day. Together with my customer team, we've been deploying anywhere between maybe 5 to 30 stacks a day on a bad day. So CloudFormation is really not just a tool for me anymore. It's almost a lifestyle choice. So when the Infrastructure as Code service team came up with some new releases in 2024, I noticed them immediately because they made a real impact to the way I work every single day. And today, I want to share some of these game-changing updates with you because I believe that it can potentially do the same for you. And I want to start by talking about development speed. Because if infrastructure as code is too slow and painful for you to get started with or to develop, then it doesn't really matter how secure it is or how much flexibility it offers you. So let's start there. How do you actually onboard a project on infrastructure as code fast? I'm sure if you were in this talk, you value infrastructure as code, you appreciate infrastructure as code, but let's do a quick show of hands. How many of you have actually deployed resources in the console by clicking on buttons and not by using infrastructure as code? Yeah, I certainly have as well. It's not a big deal, and my team would say that click happens sometimes. And the console is actually a very powerful tool. It's great for building POCs, it's great for playing around with services and to learn new things. But when it comes to actually onboarding your project on infrastructure as code, it can be a bit complicated because you have to go back and reverse engineer all of these manual configurations that you did. Then you have to type them out into a template and then deploy the template. This can be a really frustrating process, and this is actually the major hurdle to IAC adoption on projects. So to address this issue, in 2024, we released IAC Generator. I'll do a very quick demo for you. So it does the heavy lifting for you when it comes to onboarding onto infrastructure as code. IAC Generator is part of CloudFormation console. With it, you can choose to scan all of the resources in your account. It will take a look at everything that's there, and it will give you a really nice breakdown of everything that's deployed in a really nice pie chart. Then you can choose to create a template. And you will need to select the resources that you want to be included in your template. It will actually look at the resources you selected and kind of make suggestions for you. It will look if there's some dependency or some other relevant resources that you might want to import into your template as well. Then you click Create Template, and it will generate a complete deployable CloudFormation template for your resources. Then you can also, from this screen, choose to create a stack out of this template, and it will actually import resources directly into the stack, so you won't have to redeploy anything. So this is how we try to make it easier for you all to onboard onto an infrastructure as code. But of course, many people want to write their own templates. So we also want to help you develop your templates faster. There are many ways to do this. But the key release that came out in 2024 is that we improved the stack creation time by up to 40%. And I think we have quite a technical crowd here, so I want to dive into some details about how we were able to achieve this, because personally I found it quite interesting. This was a complete rework of the way CloudFormation deployed resources in parallel. I'm sure if you worked with CloudFormation, you know that CloudFormation deployed resources in parallel before. So if you needed, say, 3 independent SQS queues, it will go ahead and do them simultaneously to save time. But of course, most of the stacks have dependent resources. So let's take a look at the very, very popular architecture of a containerized application. Say you want to deploy an ECS service. It has lots of dependencies. ECS service needs a task definition to be already in place. The task definition itself needs ECR repository to be in place. And there are other things like a whole ECS cluster and VPC resources that are required. So how does CloudFormation handle this currently? Well, it will go ahead, it will figure out the order of resources in which they need to be provisioned, and it will do them in order. And you can see that there are these dependency chains that get created that have a direct impact on how long it takes to provision your stack. So this seems very solid, so how do we actually improve this? And to understand this better, I want to take a look at how does any AWS resource get provisioned in AWS. Let's take example of an IAM role. Maybe some of you have noticed that if you try to create an IAM role in the console, it gives you a response really fast, in under a second. But when you try to create a role using CloudFormation, it often takes much longer. So what's actually happening there? AWS resources get provisioned in 2 phases. First phase, milestone, I should say, is configuration complete milestone. So this is when the role is actually getting provisioned in your account. You see it there. This step is very, very fast. But then the role itself or any other AWS resource needs to stabilize. And this means that IAM service has to go behind the scenes and do some work for eventual consistency. And only after this has completed, your role can be assumed in your account. So two key phases. How does CloudFormation handle this? CloudFormation is basically waiting for every single resource to completely stabilize before it proceeds to start creating its dependency. But the key insight here is that you don't always have to wait for the resource to be completely stabilized before going ahead and provisioning the dependency. So this is the new deployment strategy that CloudFormation uses. It's called optimistic stabilization, and it looks something like this. We start provisioning the dependency as soon as the resource that is dependent on has reached configuration complete phase, not the stabilized phase. And this happens much faster. Then all of the resources can kind of stabilize all together at the same time. Of course, this saves a lot of time on stack creation, and this is how we're able to achieve stack creation times of up to 40% faster. We didn't just change this behind the scenes. You probably noticed now you can have these detailed statuses in the console. So for every resource, you know when it has reached configuration complete phase. And you can also check for the entire stack when it has been configured. And this happens much sooner than the stack stabilizes. So this is actually very useful if you have some kind of CI/CD, maybe automated testing, because you can start running automated tests on your stack when the configuration has completed, but it has not yet stabilized. Yeah, by the way, I hope you really enjoyed my PowerPoint-driven timelines. I was actually inspired by another release in CloudFormation console, and it's the deployment timelines. So now, live during any stack deployment, you can have this really nice timeline for every resource. And it will tell you about when a certain status has been reached for any particular resource in your stack. And actually, I found this timeline very useful because by kind of tracking, the deployments that I did, I was able to see how I can make very small tweaks to my template, like change the order of the resources, and it would actually improve my stack creation times. Okay, so apart from just raw provisioning speed, how can we help you develop your templates faster? And of course, number one thing is spotting errors faster, so you can start fixing them sooner. So there are a couple of new things we added that allow you to see the errors in your templates faster. First of all, we added a bunch of pre-checks for your templates before we actually start creating the stacks. And to give you an example, there's a new property value check that is being run, and it allows us to spot errors 6 times faster on average, and for certain AWS resource types, up to 17 times faster. There's also another quality of life improvement that was added that I was really excited about to do with custom resources. So CloudFormation has this feature called custom resources. It basically allows you to bring your own code that will execute inside a Lambda function while your stack is being deployed. And it used to be that if your custom code had a bug and it would error out, and this would happen to me all the time, the stack deployment would actually hang for 1 hour. It was just a default timeout period of 1 hour. And 1 hour is a really long time to wait before you can go ahead and start fixing your mistake. So what has been added recently is that you can actually specify custom timeout periods, say 10 seconds. So you don't get stuck when you actively changing your code, releasing it, testing the stack, and etc. Now, after we catch your errors, we also try to help you troubleshoot them faster and fix them faster. One of the cool new features is that now there's a deep link between CloudFormation console and CloudTrail. So if your template errors out, you can click on View Root Error button, and it will give you a link directly to CloudTrail log, directly to the API call that has caused your stack to fail. So it makes troubleshooting much faster. You don't have to go anywhere to find the logs. We also have Diagnose with Amazon Q. So Amazon Q, for kind of a common set of template errors, will analyze your stack. It will analyze the context where your stack is deployed, and it will give you a plain English explanation for what has happened. You can also click on a button, I think it's called Help Me Resolve, and it will give you suggestions for how to fix your code or some of the troubleshooting steps that you might want to take. Okay, I wanted to mention a couple of productivity boosting tools that I'm sure a lot of you are familiar with, but they have had changes over the course of last year as well. First, CFN Lint, super popular tool. It basically allows you to make sure that your template is deployable and is syntactically correct before you go ahead and try to deploy it. We released the GA version of the tool in 2024. It's so popular that we offer IDE support in VS Code for CFN-Lint. So if you use CloudFormation and don't use CFN-Lint, please install it. It will save you so much time. Also, of course, our GenAI-powered assistant, Amazon Q, it can generate templates for you. It can analyze snippets of code for you. It can even give you advice on how to set up your entire AWS infrastructure. Yeah, moving on from CloudFormation, I'm sure there are lots of people here who love CDK. I know that Brian is a big fan of CDK. Of course, any improvements to CloudFormation service improve CDK as well, because as Jonah mentioned, CDK is built on top of CloudFormation. But there are a few releases that are specific to CDK that I wanted to mention. We released a set of new L2 constructs in 2024. Most notably, Amazon VPC with subnet configuration. This was the most commonly used resource in CDK that didn't have L2 construct support, and now it does. Also, there was voting that took place last year, and Amazon CloudFront with Origin Access Control was voted the most desirable L2 construct. So due to popular demand, it was released last year as well, alongside a couple of others that you can see on the slide. And the CDK team is, as always, continuing to work with the open source community on improving the developer experience. So they added a couple of features like garbage collection in S3 buckets and ECR repositories after your deployments. We also now support IAM role session tags. So this is a requirement if your CDK deployment is going to take over an hour of the time. Wow, there was a lot of ways to speed up your process, speed up your development. But of course, once you actually start deploying to production, speed becomes less important, and it's the safety of your deployment that becomes paramount. I want to quickly just mention one new feature to do with change sets that allows you to make deployments in a safer way. So tools like CFN-Lint can tell you if your template is deployable and syntactically correct, but it doesn't tell you what will actually change. How will your environment change? What are you trying to deploy? And CloudFormation has change sets for this. They have been around for a very long time, but they only used to tell you if some kind of resource was going to be created, deleted, or changed in some way. It wouldn't say in what way exactly. And now change sets go much further. They will actually give you the before and after values for certain parameters in your template. So I just want to highlight this with a quick example to kind of visualize the impact of this. Say I want to make a change to my stack, my template. You see I'm trying to deploy a Lambda function. I make a change in the code, I push it, and then I generate a diff. This is what I see, and this leads me to believe that it is the runtime of the function that might change and the role. But then I generate a change set, and it actually reveals the truth. And you can see that the role doesn't change because of the way the parameters resolve. They resolve to the same value. And in fact, it is the memory size and the runtime of my Lambda function that's going to change. And specifically, it gives you the exact values that it's going to change from and to. And these kind of insights are really essential to make sure that your production deployments are secure and safe. So keeping that in mind, we also released this cool new feature for those of you using Git sync integration with CloudFormation. CloudFormation will now automatically comment on your pull requests with a generated change set. So if you're reviewing somebody's PR, you can see exactly the values of the properties of the resources that are going to be deployed or changed. Right, so now the big question becomes, if you work in a big team, how do you govern all of this infrastructure as code? How do you make sure that everybody follows the same rules? And I'm going to hand over to Jonah, who's going to talk about some of the new features to do with governance and also set the stage for Brian later.
Thank you so much, Vera. And what a whole bunch of features, right? It's crazy, and you can expect more of this sort of stuff going forward. I want to cover the last section, which is governance control, right? So there's this dilemma, right, in software engineering, and infrastructure as code is no different, right? So we have developer freedom versus security and compliance. So put your hand up if you think that speed is number one as a developer and has to be the top priority. Okay, and then we have this balance, right? So put your hand up if you think that security and compliance has to be the number one priority at all stages. Okay, good stuff. And yeah, as we might expect, right? The CloudFormation team and the infrastructure as code team recognize this balance, and they're trying to do both at the same time because there are a lot of win-win scenarios, and we want to cover some now, right? So we have this thing called the golden path, which allows developers to basically use pre-approved like templates, maybe pre-approved databases, images, things like this in your infrastructure. So they are pre-approved, so it can sometimes become a bottleneck, right? So this approach, really good on safety, but can sometimes suffer on developer creativity. There are then as well detective rules. And the difference here is that these are rules applied after the fact. So let's say, for example, we deploy the infrastructure. You will then see the detective rules pick up on various different things. So they might check who did what, check the instance type, check what happened, right? The problem is that this can often catch things a little too late in the process, right? So what the CloudFormation team did was create this concept called CloudFormation hooks. And it basically runs those detective rules, but in advance of you deploying the infrastructure. So it'll actually, when you click deploy in CloudFormation or our infrastructure as code services, you can use these hooks to basically catch it in advance. And it could save a lot of headache down the line when you're deploying. And what's awesome is we've got two cool ways to deploy them, right? Developers like writing in languages of their choosing, which I mentioned earlier. So you can create these hooks on Lambda, right? Allowing them just to do that. You can also use CloudFormation Guard as well, which means that you can create these hooks. It's like a subservice of the CloudFormation service. So again, definitely recommend checking those things out when you're like building your infrastructure as code, and can save you a lot of time when you're doing so. But at this stage, right, I remember meeting the Tynes team 3 years ago, and seeing what they've accomplished in 3 years has been truly incredible, and it's been a really fun 3 years. As I mentioned, Tynes are now a unicorn, which is very recent and awesome. And one thing we noticed working with them was that infrastructure as code was really enabling the Tynes team to like scale to a global level. And that's why I wanted to invite Brian today to talk to us a bit about that journey. Thank you very much.
Hi, so yeah, I'm Brian. I'm running the engineering team at Tynes, and we've been using AWS CDK and therefore, I guess, CloudFormation since we migrated into AWS back in 2020. So I'm going to take you through a little bit of a journey today, tracking our sort of evolution of our architecture from 2020 to today. Before I do that, just a quick sort of piece of information about what Tynes is. So Tynes is a platform that allows you to build and run workflows to automate your manual or repetitive work. For example, security teams will use us to handle alerts, triage those alerts, maybe remediate them automatically, perhaps to isolate a compromised device. Or IT teams will use us for onboarding or offboarding to maybe help get new hires up to speed and get them signed into all of the different tools they need to do their jobs automatically and quickly. But really, you can use it to kind of build any kind of workflow where you want to string together a bunch of API calls. My own team, software engineering team, use it to actually marshal our continuous deployment pipeline. If you want to know any more about Tynes, you can check our stand at B59. So first off, we're going to rewind back to March 2020. Tynes had just raised its Series A. I joined as the first engineer. And at the time, our limited cloud infrastructure was hosted on a different provider. I won't say name. It was hand managed and a little bit more basic. So yeah, we had a very simple Rails app at the time, and used common tools you would see there, like Sidekick for background workers that was actually running those workflows our users defined, calling out to the APIs that they had configured Tynes to call out to. We had a virtual server per customer where we actually installed the Postgres database right onto the server and along with the Redis cluster. Deployments of our app were like git pull and a bundle install. We did it like once a week with some downtime. It was all pretty early on at that point, I suppose. Around then, we also had a self-hosted offering. We basically took all those components, put them in Docker containers, threw in a zip file along with a Docker Compose file and a couple of helper scripts and sent them to our customers. So we kicked off our migration into AWS back in June of 2020. And from the very beginning, we knew we were going to need to use infrastructure as code. We had this approach of having separate infrastructure for customers, an approach we still have to some extent to this day. And we knew that ClickOps just wasn't going to scale for us. I had previously had a bunch of experience with CDK, and I just found the authoring experience so much easier than kind of writing those raw kind of CloudFormation templates. And Yeah, here's actually our very first commit that we made on our journey into AWS. You can see we're starting at the very beginning here. We're actually like provisioning the user accounts that we would then use to log into the AWS console, so the very start. You can see at the bottom as well some of the early seeds being sown for deploying this, our infrastructure as code through a continuous deployment pipeline. We did later switch to SSO accounts through IAM Identity Center for human accounts, but I do still maintain that IAM is a really, really great place to start with CDK because you're able to do things like this. So this I actually grabbed from our code base just right at this moment, and it's a really good illustration of the power of CDK for these things. Because what I'm doing here is I'm creating a role and I'm configuring it to allow a user to assume that role. Now this user, it turns out, is actually from a different AWS account entirely, so I'm setting an external ID, following all the best practices there. And then I'm granting access to that role to read from a AWS bucket. So I'm granting access to an external account to read from this bucket. And anybody who's used CDK to do this and also maybe configured this directly on the console, hopefully will agree with me in the, I guess, finding I had that I find this so much easier to get right and enforce all the kind of minimum access kind of controls you want to have, and to not mess up and accidentally expose access to your bucket to somebody you don't want to expose access to. I'd go so far as saying, honestly, CDK solves IAM in a bunch of ways. It's so hard to get right in any other way, and I just find it so much easier with CDK. That last line where we had that grant read kind of line, it's a really interesting one, because behind the scenes there, we're actually going to generate a whole ton of different CloudFormation configuration. And that abstraction really is the sort of the power that CDK is giving us. And that power of abstraction is something I'm going to touch upon a little bit over the next few minutes. Because I think the reason CDK has stood the test of time for us is that when we're talking about code, in infrastructure as code, but we're talking about CDK, we're actually talking about a fully fledged programming language in the way you're not quite when you're talking about JSON or YAML or XML or some sort of statement language like that. And in our case, we're talking about TypeScript, fully fledged programming language. And that means we get to treat building infrastructure as an exercise in software engineering. But I'm going to run back to our timeline now, and we're going to fast forward from March 2020 to July 2020. So we had started our migration into AWS in June of 2020. By July, we were done pretty fast. Well, we cheated. So we actually just took that self-hosted installation I showed you earlier, dumped it onto an EC2 instance, and called that job done. So this was actually how it manifested for us in CDK. So it was a bunch of work really to put together an EC2 launch template. We were then using our own system, so we were using Tines to call EC2 APIs directly to manage the lifecycle of these EC2 instances. The key thing here is the mention of like management scripts and bootstrap scripts. So we did something kind of crazy. We just had a bunch of, I guess, shell scripts that were handling the installation of Docker and management of Docker Compose to do all the kind of coordination of containers on those EC2 instances. But we knew that this was far from the ideal architecture. We knew there were loads of AWS services we just weren't taking advantage of at this point. But as a software engineering team, we've always practiced shipping early and often. With everything we do, we kind of search for that, like what's the smallest scope of a change we can make? Let's get that change made. Let's ship it. Let's learn from let's find out what we get from feedback, learn from it, and iterate from there. And this stepping stone allowed us to very quickly get into AWS. We also used some tricks at this point with Nginx to make our software app deployments in zero downtime, which allowed us in turn to move to continuous deployment for our kind of feature development. And that's one of the great tricks, I guess, we get to pull when it comes to writing software. Building things with software, unlike pretty much anything else, allows you to change things. Code is malleable. And with our infrastructure, with this approach using infrastructure as code, we wanted to take that same, I guess, energy and apply it to our infrastructure as well. So we knew that architecture wasn't our final destination at all, but it was a very useful step we could very, very quickly take in the right direction. And moving along then on our timeline, the next major sort of iteration comes in March of 2021. We call it Scalable Stacks at the time. I say iteration because this is still far from an ideal architecture. And we knew that, but again, it was a useful step we could take in the right direction. Basically, we yanked the persistence layer off these EC2 instances and put them into the correct AWS services. So RDS for the database, Elasticlash for the Redis cluster. And this allowed us to vertically scale that part of the architecture and then horizontally scale the remaining workers on the EC2 instances. And at this point as well, we were no longer calling EC2 APIs directly to manage the lifecycle of these stacks. We were fully managing them under CDK. And here was what a full diff looked like at the very end of all of this to ship one of these stacks for us. And what you're seeing here is some infrastructure as code that's starting to deal in just a slightly higher level. It's a little bit more abstracted. It's talking a little bit more in the concepts and terminology that matter to us as the Tynes engineering team, rather than talking about the terminology and concepts that like CloudFormation cared about. It's a leaky abstraction for sure. It's not perfect. You can kind of see the direction. One of the great joys I get when I'm writing software is when I'm able to model real-world concepts and get my abstractions right in such a way that you can really get your higher-level code to read with just incredible kind of precision and clarity. And when you're using a fully fledged programming language to describe your infrastructure, you get to use abstractions. You get to encapsulate complexity to make it all a little bit easier to work with. So we were pretty small teams for all of this. I don't think at any point in this timeline we got above 10 people. And we had a lot of product features to go and build. So this architecture at this point, as imperfect as it was and as imperfect as we knew it was, it did last us pretty well for a year and a half. But we did make a bigger move in November of 2022. We got rid of those weird scripts managing Docker and moved to proper container orchestration through ECS. So yeah, no more shell scripts. And this is looking a lot more like an ideal architecture, or a best practice one at least, where we're using ALBs. We have different ECS services for our web and worker processes. And really most of the work in getting to this architecture was actually in moving some of the sort of supporting services into containers, for example, for observability. But yeah, this really did open up a bunch of opportunities for us then later on too, because we were able to not only have ECS services for our web and worker processes, we were able to do different ones for different types of traffic on the front end. We're also able to have different services for different kind of background jobs too, so we could scale them in different ways. Rather than showing you the last change for this one, I'm going to show you the very first one we made. And this is pretty much the whole thing. So what we did here is we shipped a change to create an empty ECS cluster. So this is completely useless on its own. But we put it in a PR and we shipped it, and we made sure that we did indeed get an empty ECS cluster created. And that's exactly how we like to work when we're building our product features. It's like continuous, like small digestible PRs and fast shipping. Yeah, and this is where we really appreciate, I guess, that work from AWS to speed up all of their operations when it comes to cloud infrastructure. The more they do that, the more we're able to actually really live this ideal of shipping infrastructure changes in exactly the same way that we do with our product features. So we were finally at a nice architecture at the end of 2022. A few months later, we followed up and adopted CFN lint, as Vivara was describing. We've always been extreme fans of linting, I'd say, turning it on for literally every programming language and framework we can. We've always just generally invested really heavily in developer tooling and any kind of scripting we can to help us speed us up in our development, make us more accurate. So we added CFN lint right into our continuous deployment pipeline. We also built some tooling so we could run it out locally too, right in our development environments for extremely fast feedback cycles. Highly recommend doing this. This made us so much faster when it came to developing a series of changes for our infrastructure. And one of the great tricks I think we get to pull when we're building software is that we can write code to help making write code easier. So if your infrastructure is just code, you get to lean on all of that great developer tooling to make building your infrastructure that bit faster and more accurate. So those are the major milestones, I would say, of our evolution, all the while using CDK. Over the last year, we've migrated from using Fargate to EC2 ECS as the capacity provider. We just hit a point where the scale and cost that made more sense for us. We're also looking at the minute at using Aurora serverless to help with some of the stacks that are a little bit spikier. But generally speaking, there haven't been any more major architecture changes since. To think about maybe where we're going to go next with all of this, I'm going to perhaps unsurprisingly talk a little bit about LLMs. So back in September of 2024, we released Workbench. So Workbench is an LLM-powered chat that actually uses AWS Bedrock under the hood, but it also connects to these Tynes automation primitives to allow you to connect to your live systems, to query data about those systems in real time, and also to take action within those systems. And as we were searching around for different use cases that we within our engineering team could use for Workbench, we came across this Cloud Control API, which was quite interesting. Caught our attention because it's one API call that will return information about almost any resource in your stack, all in a nice LLM-friendly format. So we felt like Workbench and Cloud Control could be quite a cool combination. So let's see it in action. All right, so I kicked this off with a very simple ask. Tell me about a database for a particular time stack. I've hooked Workbench up here to a couple of different API endpoints. So the first one here is a CloudFormation call to list the resources for a stack. And it does that to orient itself and figure out generally what's going on in the stack. After that, it's using this Cloud Control API I mentioned to query for information about, at first, the database cluster, and then a database instance. Those are actually two completely different types of resources, but I'm using just the same API call to query for both of them. It's then giving me a nice summary of what it's found out. And at this point, I could go on and I could further try and interrogate the infrastructure in the stack. I could maybe ask it about those S3 import and export roles, and that one API would nicely return information for me. But instead, I'm going to use some of the information I've discovered here around cluster identifiers to go on and further query CloudWatch to find out about some metrics about this stack or this database. So I do that and it returns some information. So I've gone from just generally having a high-level sense of like, I want to know some stuff about this stack, to discovering enough information to then go on and query about metrics about that stack. In this case, the stack is pretty healthy. There's nothing too crazy going on here. But if there were any maybe pressure points, I could then from here go on and ask Workbench to go ahead and scale up my stack for me. So let's see what that looks like. I've also connected Workbench up here to our GitHub repo. I've told it where to find the different files that define our stacks and given it the ability to read those files. But other than that, it's really just doing its thing here. It's loading a file, it's having a look, it's reasoning about what changes it needs to make, and it's proposing a change. It's creating a PR now, and it's going to prompt me to confirm if I want to create the PR. It does that for any action that creates, updates, or deletes data to make sure it doesn't run away and do anything you don't want it to do. But it creates the PR for me, and then it's going to give me a nice little summary of the change it made, why it made that change, and what the potential impact of that change will be. But it has created a PR, so let's go ahead and have a look at the PR. And there you can see it's created a PR to change my CDK-defined infrastructure. So yeah, that was a whistle-stop tour, I guess, of our infrastructure. A little bit of a description of how we use CDK, how we've evolved it over the years. I've shared also some thoughts about how I think there are a ton of benefits to treating the building of your infrastructure as an act of software engineering. And maybe that's prompted some thoughts about how, in this world of LLMs helping us to write software, that we're in for some interesting times there too. So yeah, I'm going to hand back to Vivara to wrap up, but thank you very much.
Huge thanks to Brian and the Tynes team for this awesome demo. To be honest, I love Cloud Control API. It's just amazing how general it is. It applies to all of the AWS resources in your stacks. It's incredible, the kind of things that you can build with it. And I think this demo highlights really well what we've been talking about today, and it's that infrastructure as code used to be just about provisioning your resources, and now it has transcended into something that kind of allows for agility, innovation, and much, much smarter workflows between your teams. And on this note, if something has sparked your imagination or you felt like you need to brush up on a couple of things, you're in luck. Skill Builder is available, it's free, it's packed with content, so go ahead, go to skillbuilder.aws to create an account. And finally, if you like this talk, or even if you didn't, you just needed some space to vent somewhere, please scan the QR code, put all of your thoughts in the AWS Events app. I personally can't wait to read all of your feedback. It helps us get better, helps us improve on our speaking engagements. Huge thanks to my co-speakers for doing a great job. Thank you for your attention, and let's go enjoy the rest of the summit.